Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to uh, some basic concepts related to hydrostatics or fluids at rest. So previously we discussed about intermolecular forces in fluids. So in this video we are going to discuss about another important phenomena associated with fluids, which is surface tension. And it is because of the intermolecular forces which exist between the fluid molecules or liquid molecules. So just have a quick recap. Intermolecular forces are of two types: cohesive force and adhesive force, which is because of the force of attraction between molecules of the same substance, that is force of cohesion, and molecules of different substance, that is adhesion. Okay, so when forces of attraction are between uh, the same substance, molecules of the same substance, be it liquid or solid. So when the forces of attraction are between the molecules of the same substance, be it liquid or solid, okay, same kind of matter, same substance, that force of attraction is called as force of cohesion. And when it is between different molecules, molecules of different substance, mainly liquid solid, in that case the force of attraction between molecules of different substance, that is called as force of adhesion. So how this force of cohesion or adhesion or the intermolecular forces, they contribute towards surface tension. Okay, so surface tension is basically the property of liquid at rest, hydrostatics, by virtue of which the top surface, okay, the top surface of the liquid, it behaves like a stretched membrane. Okay, so here this top surface, it is behaving like a stretched membrane, and it is a little bit pulled inwards. Okay, it is pulled inwards, downwards. This phenomena is called as surface tension. It is not straight, it is like this kind of a, pulled inwards. It is because of the downward force of attraction between the liquid molecules. So let us try to understand it. Let us say we have this liquid container which is open to the atmosphere, air pressure. So here there are different kinds of different molecules present. So let us say we have two cases where we have a molecule, all the molecules which are within the liquid, that is within the container, and the molecules which are at the surface. Okay, this two cases, all the molecules that are inside the container and all the molecules which are at the surface. So it is because of these molecules at the surface, this surface tension phenomena is there. Now for all the molecules which are inside the container, except for those at the surface, there is cohesive force of attraction by other liquid molecules, which are expressed as these arrowheads, equal in magnitude, opposite in direction. So these molecules which are present at all these points, okay, these molecules which are present at all these points, they cause force of attraction to this molecule here. They are equal in magnitude, opposite in direction. It causes a force of attraction towards this molecule, this causes a force of attraction towards that molecule, and in this way equal and opposite forces are exerted on each molecule which is present inside the surface, here, anywhere. So the net force on the molecule, the net force is 0. The net force is 0. See this molecule like this, okay. So here, sorry, this is not in the upward direction, it is in the downward direction, okay. Sorry, this is not F1, F1, okay. Here it is, let's say F2, here it is also, it is F2, like this. So everything gets cancelled out, or like this, F3, F3, equal forces of equal magnitude in opposite direction, F4, F4, like this, F5, F5. So all the forces, they are equal in magnitude but opposite in direction, acting on the molecules which are inside the container, okay. So because of that, the net force on these molecules, it gets cancelled out, and it is, the net force is equal to 0. It is only for the liquid molecules which are inside the container. But for the molecules which are present at the surface, here towards it, from in the downward side, there are liquid molecules which exert force of attraction towards it, but in the upward side it is only air pressure, the force due to air pressure, and that force is very low as compared to the cohesive force between the liquid molecules. So as a result, there is unequal pressure acting on the liquid molecules at the top. Here the cohesive force downwards, it is high, okay. The cohesive force downward is high, but the force due to air, that is low, okay. The air pressure is low, but this cohesive force, because of the liquid molecules, that is high in magnitude. It is attractive in nature. So all the molecules which are present here, they cause cohesive force of attraction which is high in magnitude as compared to the air pressure, the molecules of air. So as a result, the molecules which are present at the top, they get a little bit pulled downwards, okay. They get pulled downwards. All the molecules which are present at the surface, they get a little bit pulled downwards, okay. Here, 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 like that, because of more force of cohesive force of attraction as compared to the air pressure force. So as a result, the top surface of the liquid, it behaves like a stretch membrane. If it would have been equal force, air pressure force and the molecular force of attraction would have been equal, in that case it would have been straight. But here there is a net downward force. As a result, the air pressure force is less. So as a result, it behaves like a stretch membrane, not straight, but like a stretched membrane, which is slightly curved downwards, okay, slightly curved downwards, okay. So this is the reason why whenever the liquid at the surface is always in, slightly curved, slightly in motion, always curved downwards. It is very hard to notice, but it is always curved downwards. So if we want to measure this force of surface tension, then let's say we consider a portion at the surface by drawing a line in between 2 points, okay. On the top surface of the liquid contained in the container, on the top surface, we consider a region, 2 portions A and B, 2 points, we join it by a line AB. Now the downward cohesive force which acts because of this cohesive force of attraction between the molecules B, which are located at the surface, that force acts on both direction on either side of the line AB, equal in magnitude, opposite in direction. So the surface tension that is expressed as surface tension T is the force acting on either side of the line AB, okay, the force acting on either side of the line AB, which means this, divided by the length of the line AB, that is AB, this length. So that is the force of surface tension. Okay, F by L, the total length of the line, it is equal to L, the total length AB is equal to L. So surface tension is simply force, this force acting on either side, equal in magnitude, opposite in direction, and the length of the line across which it acts. This is the force of surface tension. Here it is not exactly just force, it is force acting per unit length. So its unit will be Newton per meter. This. So again, let me try to make you understand. If we pick the top surface, okay, of a liquid contained in a container, this is the top view, and we consider any two points A and B, we join them by a line of length L, the length of the line AB is equal to L. Here, because of the cohesive force of attraction between the liquid molecules, force acts on either side of the length AB, which is equal in magnitude, opposite in direction. Surface tension is simply this force acting on either side, which is equal in magnitude, opposite direction, divided by the length of the line joining the 2 points A and B. Simply, surface tension T is equal to force by length or force per unit length. Okay, its unit is Newton meter. For example, the surface tension of water is about 0.075 Newton per meter. Okay, so for every 1 meter on the surface of water, there exists a force of 0.075 Newton acting per meter. So some properties of surface tension. Surface tension is a scalar quantity. It has no specific direction for a given liquid. Force is a vector, but force per unit length, surface tension, it is scalar. Again, it is not simply force, but force divided by length, or force per unit length, and it is the force which is needed to hold the liquid, the top surface of the liquid together, and it always acts tangent to the liquid surface. It always acts tangent to the liquid surface. Okay, so here the force of surface tension would always act tangent to the liquid surface. So if it is curved like this, it will act like this, tangent to the liquid surface at each and every point on the curved portion of the liquid surface, the stretched membrane. Then the surface tension of a liquid is dependent on temperature, and it decreases with increase in temperature. So some factors which affect surface tension is nature of the liquid, composition of the liquid, chemical composition. So mercury has a very high surface tension, 0.55 Newton per meter, and surface tension of water is 0.075 or 72 Newton per meter. Then another thing which affects surface tension is the presence of impurities. Presence of impurities in a liquid decreases its surface tension. Okay. Then temperature. The surface tension, it decreases with increase in temperature. For example, for water, surface tension is 0.0756 Newton per meter at 0 degrees Celsius, and it is 0.072 Newton per meter at 20 degrees Celsius. And the temperature at which the surface tension of a liquid becomes 0 is called as critical temperature. This mathematical equation, it gives us variation of surface tension with temperature, where the surface tension at a particular temperature T subscript T is given as T subscript O 1 minus alpha T, where T subscript T is the surface tension at a particular temperature T degrees Celsius, T0 is the surface tension at 0 degrees Celsius, Alpha is the temperature coefficient of surface tension and T is the particular temperature in degree Celsius. Okay, so these are some of the important concepts related to surface tension which we discussed. So it is simply the force, the tangential force acting on the top surface of the liquid contained in a container because of the the imbalance in the force, the cohesive force between the liquid molecules and the force due to air pressure, as a result of which there is a gradual downward pull at the liquid surface, causing it to be slightly bent or curved, behaving as a stretched membrane, and it acts tangential to the surface, and it is given by the value F by L, where we pick a certain length on the surface of the liquid with force acting in equal magnitude opposite direction on either side, and it is simply force per unit length or force acting per unit length on the surface of the liquid. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.